This is lesson 7, function operations. This is really a recap from unit 1. Unit 1, we were doing operations with polynomials. This is doing the exact same thing, just in function notation. So if we take a look at the first question, it says, given that f of x equals x squared plus 7x plus 12 and g of x equals x plus 4, find f of x plus g of x and express the result in standard form. So here they're telling us to take f of x, which is the x squared plus 7x plus 12, and we are going to add to it g of x, which is the x plus 4. Just like during unit 1 with the operations with polynomials, every time you set these up, you should be plugging them in with parentheses. Your functions really are just all polynomials in function notation. So it's really the exact same concept. Addition, the parentheses don't make a difference. There's nothing in front of either of these parentheses that we have to distribute in. So you really technically for addition don't need the parentheses, but I would be in the habit of always putting them just to be on the safe side, that you don't forget to put them one day when you really need them. So combining like terms, we have just an x squared, 7x plus x is 8x, and 12 plus 4 is 16. That is our final answer. It says standard form, which is what that is. Standard form does not mean factor. It just means combine like terms, have your exponents go from the highest down to the lowest. So question 2 says, given that f of x equals x squared minus 9x plus 18 and g of x equals x minus 6, find, here's a little bit of a different notation, f minus g of x and express the result in standard form. This means the same thing as saying f of x minus g of x. They're really saying you're going to take f, which is the x squared minus 9x plus 18, and you're going to subtract from it g, which is the x minus 6. This x does not mean that you are multiplying anything by x. Like I said, it's kind of just the notation that we are using, f of x, g of x, which is just those original polynomials. So you're really just taking f and subtracting from it g. So subtraction, here's where the parentheses do make a difference. You do have to distribute that negative just like we did during unit 1. So you get negative x plus 6. So combining like terms, you should get x squared minus 10x plus 24. Again, standard form, you're going to leave your answer the way it is. Question 3, find f of x times g of x in simplest standard form. If f of x equals x squared minus 17x plus 72, and g of x equals x minus 8. So they are telling us to just take the two, x squared minus 17x plus 72, and multiply with it x minus 8. So we're going to distribute. X squared times x is x cubed. X squared times negative 8 is negative 8x. Negative 17x times x is negative 17x squared. Negative 17x times negative 8 should be positive 136x. 72 times x is 72x. And 72 times negative 8 should be negative 576. Now we're going to combine like terms. We're going to have Oh, that first one should be negative 8x squared when we did negative x squared times negative 8. Lost an x squared. So combining like terms, x cubed, negative 8x squared, and negative 17x squared should be negative 25x squared. Positive 136x plus 72x should be positive 208x. And the negative 576 comes down. That is your final answer. Number 4 says, given that f of x equals x squared plus 4x minus 45 and g of x equals x minus 5, find f divided by g of x and express the result in standard form. Again, this notation is the same thing as saying f of x divided by g of x. They mean the same. So you're taking f of x, x squared plus 4x minus 45, and dividing by x minus 5. So you have two options here. These are simple operations, so you can do it with our simplifying rationals that we did, where we factor the top, AM method, add to 4, multiply to negative 45, should be x plus 9, x minus 5. On the bottom, we have an x minus 5, so they cancel. So your answer is just the x plus 9. Option 2, you can do the reverse tabular method. We're dividing by x minus 5. Highest exponent on top is 2, the bottom is 1. 2 minus 1 is 1, so we draw one line down. So we have our x squared, our positive 4x, and our negative 45. So we have x squared in here, so x times x is x squared. X times negative 5 is negative 5x. Outside minus inside. Your next top box is 9x. X times 9 is 9x. And 9 times negative 5 is negative 45, which adds up. So our answer is x plus 9. Same answer both times, just two different ways to do it. So whichever way you prefer for the division. Number 5. For all real values of x, if f of x equals x minus 3 squared and g of x equals x plus 3 squared, what is f of x minus g of x expressed as a polynomial in standard form? So setting up, f of x comes first, that's the x minus 3 squared, minus g of x goes second, that's the x plus 3 squared. Before you can do subtraction, order of operations, exponents go first. So off on the side, I'm going to do the x minus 3 squared, and then I'll do the x plus 3 squared, and then we can go and subtract them. So x minus 3 squared, we're going to write it twice and double distribute. X times x is x squared, x times negative 3, negative 3x, negative 3 times x, negative 3x, negative 3 times negative 3 is positive 9. Combine like terms. So x minus 3 squared becomes x squared minus 6x plus 9. Now we're going to do the same thing with the x plus 3 squared. We're going to write it twice. Double distribute. X times x is x squared. X times 3, 3x. 3 times x, 3x. 3 times 3, 9. Combine like terms. We get x squared plus 6x plus 9. So x plus 3 squared is x squared plus 6x plus 9. Notice I still have parentheses around them because you are subtracting that entire x squared plus 6x plus 9 that came out of the x plus 3 squared. So distributing my negative, I have x squared minus 6x plus 9 minus x squared minus 6x minus 9. So combining like terms, the x squareds cancel. Negative 6x and negative 6x is negative 12x. And then the 9's cancel. So your final answer is just the negative 12x. Number 6, we're given f of x and g of x. It says express, so we're going to set this up very carefully. F of x, so we're going to start with f of x, 2x squared plus x minus 3, times g of x. So we're going to multiply with g of x, which is x minus 1. We're then going to subtract from it. These square brackets are just like giant parentheses. A lot of times they do that when there's going to be parentheses inside to help you distinguish between all the different parentheses. So now they're saying take f of x again, so 2x squared plus x minus 3, and we're going to add to it g of x, which was the x minus 1. Okay, a little order of operations. Technically, those parentheses, that square bracket is a parenthesis. Technically, that goes first, combining like terms. It's addition, so we don't have to do anything with the parentheses that it's set up with. You could just go straight to combining like terms. We get 2x squared plus 2x minus 4. In the front, we are multiplying. So I'm going to distribute to multiply right now. 2x squared times x is 2x cubed. 2x squared times negative 1 is negative 2x squared. X times x is x squared. X times negative 1 is negative 1x. Negative 3 times x is negative 3x. And negative 3 times negative 1 is positive 3. I'm going to combine like terms. I have 2x cubed minus x squared, or minus 1x squared, minus 4x plus 3. And now this entire polynomial is being subtracted. So I'm going to distribute the negative at the same time. If you want to do it in separate steps, go for it. But you should get negative 2x squared minus 2x plus 4. And now we can combine like terms again. So we have 2x cubed, negative x squared, and negative 2x squared is negative 3x squared. Negative 4x and negative 2x is negative 6x. And positive 3 and positive 4 is positive 7. That is your final answer. For number 7, it says if g of c equals 1 minus c squared and m of c equals c plus 1, then which statement is not true? Personally, I think the easiest option here is going to be to do our little SAT trick. Otherwise, you are setting them all up. So if I were to do number 1 the right way, on the left, you're doing g of c, which is 1 minus c squared, times m of c, which is c plus 1. And you're going to multiply out the entire thing. 1 times c is c. 1 times 1 is 1. Negative c squared times c is negative c cubed. Negative c squared times 1 is negative c squared. And that does match that right side. I have a positive 1, a positive c, a negative c squared, and a negative c cubed. So that one is true. We are looking for the one that is not true. So it's not answer choice 1. So you could keep doing them all by hand, or you could do my SAT trick. So to show you the SAT trick for number 2, setting up, it's 1 minus c squared plus c plus 1. And we want to see if that is equal to 2 plus c minus c squared. So remember my little SAT trick? You could pick a number and plug it in for the variable. We're using c's here. So plugging in 1 minus 2 squared plus 2 plus 1. There's the left side. I get a 0 out. Do I get the same thing when I plug it in on the right? I do, which means that they are equal. It is true, so it is not answer choice 2. So you could do that. You could do either option for choice 3. So the whole problem, it's up to you how you want to be setting them up. Make sure you go in the correct order. Number 3 does have it backwards. It says you're taking m of c, which is c plus 1, and subtracting from it g of c, which is the 1 minus c squared. And we're trying to see if it's equal to c plus c squared. So again, you could do this whole thing by hand if you want, or you could do the SAT trick. It is completely up to you. If I do my SAT trick, plugging in 2 gets me a 6 on the left. Plugging in 2 gets me a 6 on the right. If I had distributed and done it by hand, I would have had c plus 1 minus 1 plus c squared. The ones cancel, and that shows that I did have c plus c squared left over. So either option works. Now at this point, it clearly has to be answer choice 4. If you are setting it up, answer choice 4 says you are taking m, which is c plus 1, and dividing it by g of c, which is 1 minus c squared. Now, reverse tabular method, we do not do it when the bottom has an exponent bigger than the top. Every time we've done reverse tabular method, the bottom exponent has been smaller. So this one, they're actually expecting you to factor if you are doing this by hand, which is c plus 1. And on the bottom, it is dots. 1 minus c, 1 plus c. So c plus 1 and 1 plus c cancel, and you're left with 1 over 1 minus c. They're saying it's negative 1 over 1 minus c. So that's why that one is incorrect. But you could have done your little SAT trick there also. You could have plugged in a number for c and seen if they were equal. Number 8, you're given g of x equals x minus 1, and p of x over g of x equals x squared plus 7x plus 5 over x minus 1. State p of x in standard form. So this g of x down here is x minus 1, so I'm going to plug that in. And my goal is to state p of x in standard form. So your goal is to solve for p of x. You want to get p of x by itself. Now, I see some fractions here, so if we go back to one of our earlier units, if you put everything over 1, you can get an LCD. My LCD is x minus 1. So that first x squared needs the x minus 1 on the top and bottom. Same thing with that 7. it needed the x minus 1 on the top and bottom. So technically what we have is p of x over x minus 1 equals, distribute, you get x cubed minus x squared over x minus 1. Distribute, you get 7x minus 7 over x minus 1. And that back 5 already had the x minus 1, so we don't have to do anything to it. So remember, in the equations, once all the denominators are the same, you can cancel them out. So you're really just left with p of x equals, and you have all your numerators left over. And standard form, combine like terms. So we actually only have two things to combine. The negative 7 and the positive 5 in the back become negative 2. And we just solved for p of x. We got p of x by itself. So that was really just your rational equations that we had done during our previous unit. I think it was unit 3. Last question, just a throwback, just a review from an earlier unit or an earlier lesson. Remember, this notation means inverse, which means switch your x and y. F of x is your y, so switching, we have x equals 3y plus 1 over 5y minus 7. Same steps when it's a fraction. X goes over 1, we're going to cross multiply. X times 5y minus 7 is 5xy minus 7x. 3y plus 1 times 1 is 3y plus 1. Anything with a y needs to go to the same side, so I'm going to subtract the 3y from the right over to the left. You could go the other way if you want. Oops, equals 1. 7x equals 1. But now I have to add my 7x to the other side because he does not have a y, so he can't be on the same side. From here, now that the y's are by themselves on one side, I can factor out the y as a GCF. Come on. So factoring out the y as the GCF, I have y parenthesis 5x minus 3 equals 7x plus 1. And then I can divide the 5x minus 3 to the other side. So I'm left with y equals 7x plus 1 over 5x minus 3. If you had brought things to the opposite side, remember every sign in your fraction is going to be the opposite. And for example, on the bottom, if you have 3 minus 5x for that one, that's fine. All of the tops and bottoms can be like that.